Ever snapped a photo and wished your computer could, like, really get it? Not just tell you it's a dog, but see that goofy grin, the head tilt, maybe even guess the breed. That's the kind of cool stuff we're diving into today.
We're talking about this fusion of computer vision and language, right? Giving computers a whole new way to interpret, to actually interact with what they see.
Our guide for this deep dive is this document called, get this, Integrating OpenCV and Large Language Models.
Yeah, the name's a mouthful.
Bit of a mouthful, but trust me, it's fascinating stuff.
Absolutely. It's like, think of OpenCV as giving computers the gift of sight. Yeah, so they can process images, videos, all that.
Okay, so they're seeing. Then what?
That's where the LLMs, the large language models, come in. Think. The brains behind ChatGPT. That's what lets computers understand, even generate human-like text.
So we've got the eyes, we've got the language brain.
And this document, it's all about how to get these two superpowers working together.
Which is a pretty big deal, right?
Huge, because it's not just computers spitting out what they see, it's about context, nuance, the whole story behind the image.
So not just, hey, there's a dog, but more like...
More like, that's a golden retriever, probably about 2, and judging by that tail, totally stoked to see its owner.
Okay, that's impressive.
Yeah.
But what's the use?
Oh man, tons. Image captioning, for one. Imagine scrolling through social media and instead of lame tags, you get these rich descriptive captions. Super useful, actually insightful.
Can be huge, especially for folks with visual impairments, right?
Yeah.
Relying on those descriptions to see what's in a photo.
Exactly. It makes the online world way more accessible. And then there's visual question answering, VQAA. Ask the AI questions about an image. What color's the car? Or is there a cat? And boom, it answers you based on what it sees.
Like having a conversation with your computer about a picture.
Exactly. Except first we got to teach the computer to even see that picture, which is where OpenCV comes in.
All right, so how do you teach a computer to make sense of an image the way we do?
So it starts by breaking it down, right? Into these data points the computer gets. OpenCV uses things like edge detection, finding the boundaries of objects.
So instead of the whole picture, it's focusing on the key elements.
Yeah. And then there's object recognition, pinpointing those specific objects within the image. And once those features are pulled out, they're transformed into these things called embeddings.
Embeddings. Okay, now you're just using big words to make me feel lost.
No, trust me. It's simpler than it sounds. Think of it like translating a painting into sheet music. Both capture the essence, but in different languages. We're turning visual info into a language AI can understand numbers.
So it's like giving the AI a code book for the visual world, sees a circle, checks its book, and goes, ah, a ball.
You got it. And once it's got those embeddings, that's where the LLMs take over. They take those numerical representations, process them against all the text data they've learned, and bam, human-like responses.
So it's like the LLM saying, okay, I see these visual clues. Here's everything I know about those clues based on everything I've learned.
Exactly. That's how we go from pixels to a computer telling us, there's a dog chasing a frisbee in the park.
That's wild. And speaking of wild, this document mentions some really cool real-world stuff, like using YOLO for object detection and GPT for descriptions in, get this, surveillance systems.
Now, that is where it gets really interesting. Imagine monitoring a security feed. YOLO is super fast, right? Processes images in real time. Couple that with GPT, the model behind ChatGPT, and...
Okay, I'm seeing where you're going with this, and it sounds crazy powerful. But before we get ahead of ourselves, let's bring this back down to earth for a sec.
Yeah.
If you were building a security system, what would actually be the most useful info it could give you?
You're right. Easy to get carried away with the tech. Practically speaking, yeah, you'd want more than object detected.
Totally. Like, is it just a raccoon getting into the trash again, or is this something I should actually be worried about?
Exactly, and that's where GPT comes in, right? Instead of just person detected, you get a description, like an individual wearing a blue jacket and carrying a package is approaching the north entrance.
Whoa. Okay, now that's helpful. It's like having an AI detective on the case.
All about that context, you know? Going beyond just, yep, that's a thing.
This makes me want to try it out myself.
Yeah.
Earlier you mentioned this hands-on thing in the document, building a visual question answering system. How does that even work?
Oh, yeah. That uses OpenCV, of course, for the image part, but then it uses this other LLM called BERT, really good at understanding how words connect to each other.
So if I ask it, is there a cat in the picture? Bert's the one figuring out what cat and picture even mean together.
Exactly. But before Bird even gets to it, OpenCV's got to do its thing. Isolates the objects, maybe outlines the couch, the window, and hey, a cat if it's there.
So it's like OpenCV is giving Bert this guided tour of the image. Like, here's all the important stuff, buddy.
Perfect way to put it. And remember those embeddings. Big role here, too. OpenCV doesn't just point at the cat, it translates it into those numbers, the ones Bert can actually understand.
Okay, so it's like OpenCV is saying, hey, Bert, check out these numbers. They mean fluffy thing, whiskers, tail. Does that answer your question?
Spot on. And Bert, based on all its training, can be like, yep, that's a cat.
This is so cool. But is it stuck on just, like, analyzing pictures?
Nope, not at all. Remember, OpenCV can deal with text within images, too. Combine that with LLMs. Things get really wild.
You mean like scanning a document and having the computer read it? We've had that forever, right? OCR.
Sure, but OCR just grabs the text, right? This is pairing it with LLMs so they understand the meaning, the context.
So it's like the difference between a computer that can just read a recipe out loud and one that actually gets the steps, the ingredients, maybe even suggests swaps based on what you've got in your fridge.
Perfect analogy. Think about it. Summarizing their super long legal documents, pulling key info from invoices, even AI assistants that can read your messy handwriting.
Okay, that'd be life-changing. You mentioned legal documents. Could this tech replace lawyers one day?
Whoa, well, let's not get ahead of ourselves. It's more about empowering them, not replacing. Think of it like a super tool makes them way more efficient. They can focus on the strategy, the big picture stuff.
Okay, that makes sense. Enhancing what humans can do, not making us obsolete. But still, the possibilities in law, finance, even education, it's huge.
Absolutely. And it's not just about doing things faster. Think accessibility. Someone with a visual impairment, the AI can read the text, but also summarize it, explain it, all in real time. Information for everyone.
Powerful stuff. This makes me think about the creative side, too. OpenCV and LLMs, could they be used for art, music?
For sure. Generate art from a description, create subtitles for silent films, even have AI compose music based on what it sees.
Talk about a fusion of art and tech. This is all super fascinating, but it's got to be still evolving, right? This document mentioned some pretty futuristic ideas.
Right. One of the craziest is 3D object recognition. Imagine AI that doesn't just see a chair in a picture, but gets its position, its size, even what it's doing in the room.
So, like, instead of a flat image, it's seeing the world in 3D, just like us. That's insane. What could you even do with that?
Endless possibilities. Robotics, for one. Robots navigating environments like we do, handling objects with real dexterity. Or imagine architects. They just sketch their vision and bam, the AI builds it in 3D.
So no more spending hours on complicated software. You just draw and the AI gets it. That would be a game changer.
Exactly. And LLMs would be crucial there too, making sense of all that 3D data, connecting it to language, to meaning. It's like we're not just teaching computers to see 3D, but to talk about it, interact with it, all in our language.
It's like we're about to give computers this whole new way of experiencing, of understanding the world. And it's all because of this combo, the computer vision and the language AI. But is there anything this tech can't do?
Well, like anything new, there are bumps in the road, right? Accuracy, reliability, that's a big one. Just like us, AI can misinterpret things, struggle with those subtle meanings, especially when things are complicated.
So it's about making sure the AI is really getting it, not just taking a guess. Makes sense. Anything else?
Adaptability is huge. Right now, a lot of these AI models, they're trained on these massive data sets, very general. But the future is all about tailoring them, making them fit specific needs.
So instead of one size fits all, it's like custom-made AI for different jobs, different people even. What would that look like?
Imagine your AI assistant. It knows how you talk, what you need before you even ask. Or in medicine, a diagnosis tool that's been trained on your specific, unique health data. The possibilities are, well, pretty much endless.
That's wild. We've gone from AI understanding one picture to like understanding our whole house, maybe even us.
Yeah.
But we haven't even touched on all the ways this tech is being used out in the world. So we've talked about AI detectives for security and even AI architects, which is mind-blowing. But where else are we seeing this tech pop up in the real world?
Well, think about something as everyday as online shopping. You're looking for furniture, say a lamp. Right now, you're limited to searching by keywords or scrolling through endless pages of options.
And let's be real, sometimes I can barely even decide what I want, let alone find the words to describe it.
Exactly. But imagine if you could search visually using a combination of images and language. Let's say you want a lamp that would look good next to a velvet green armchair. You could actually show the AI a picture of your armchair, and it could analyze the style, the color, the whole vibe of your room.
Okay, yeah, that would be pretty cool. No more second-guessing my taste or scrolling endlessly. It'd be like having a personal interior designer on call, 24/7.
Precisely. And it's not just about aesthetics, right? Think about accessibility again. Imagine a visually impaired person being able to shop by picture, using voice commands to ask the AI to describe different clothing items or compare products.
It's really amazing how this technology could break down so many barriers, not just for people with disabilities, but for everyone. I mean, we've gone from talking about AI understanding a single image to it understanding entire rooms, our personal styles.
And we're still just scratching the surface. Remember how we talked about LLMs being trained on those massive data sets of text and code? Researchers are now figuring out how to feed visual data into those data sets.
So instead of just learning from words and numbers, the AI would be learning from the entire visual world.
Exactly. Imagine an AI that can watch a cooking video, for instance, and then actually understand the steps, the techniques, the little nuances that a chef might not even mention out loud.
Wow, that's next level. It's like you're giving AI the ability to learn by watching, just like humans do.
It's
Yeah.
true. This combination of computer vision and LLMs, it's like we're giving machines a whole new way to experience and learn about the world.
It's incredibly exciting, but also a little bit daunting to think about all the implications. As we wrap up this deep dive, what's the one big takeaway you want our listeners to remember?
I think the biggest thing to remember is this. We're on the cusp of a whole new era of computing. The lines between the physical world and the digital world are blurring. We're giving machines the ability to see, understand, and interact with the world in ways we never thought possible.
It's a lot to wrap our heads around, that's for sure. Any advice for our listeners who are feeling inspired and want to explore this technology further?
The great thing is a lot of the stuff is open source. Libraries like OpenCV are free to use, and there are tons of resources online for getting started with LLMs, even if you're not a coding whiz. So yeah, if you're curious, dive in and start experimenting.
I love that. There's a whole world of possibilities out there. A huge thank you to you for joining us on this incredible deep dive into the world of OpenCV and large language models.
It's been my pleasure. It's a fascinating field, and I'm excited to see where it goes next.
And to our listeners, as always, keep those curious minds engaged. We'll be back soon with another deep dive into a topic that's sure to spark your imagination. Until then, keep exploring and keep asking those big questions.